I'm going to go over how we use the kinematic equation in physics to analyze the one dimension of motion of objects. And these are the four kinematic equations. Sometimes I like to call them the big four. Now in a moment I am going to go over a couple of examples how we use the kinetic weight, but there is a few things I want to say briefly. First of all, it is important to remember that these equations are usual. We have constant acceleration when the acceleration is staying the same now. That means that the velocity will be either increasing or decreasing, but the acceleration will stay the same constant acceleration. Now you will notice we have four equations, and in these four equations we have five different variables. These are the initial velocity, the final velocity, their change in position, the acceleration, and the time. And we can use these equations to solve for any of these five variables. Now, in typical problems for kinematic equations, you will be given three of these variables and asked to solve for the force. You should notice that each of these equations had four variables in them. So if you are given three and asked to solve for the force, you can use for one of these equations. For example, this first equation had the change in position, the initial velocity, the final velocity, and the time. If you are given three of these things, you can also for the force. That's the way the equations work. Now I want to point out that in your textbook the initial velocity is properly presented as 0 at the velocity at time 0. I like put di because in your textbook also the final velocity is properly just represented as v1. Like to put vf, so therefore and I keep these two things separated much more easily. If I have di and if vf or the initial velocity and the final velocity, so let's actually go through now. We do a couple problems and see how we solve for the one-dimensional horizontal motion of objects using the four kinematic equations. Okay, now here is the first problem. A car is waiting, stop light, turned green when the dust oscillates from rest at rate of 5 to 5 meters per second square for time at 4.25 seconds, and we want to determine how far the car is going to travel now. I think the most important things to do and the first things you should always do when you have this problem is write down all five of the variables. That would the initial velocity, final velocity, the change position, acceleration, and the time. Write all five for this down and then write in fill in what you have been given and that you are trying to solve for the knowns and the unknown. Let's read the problem carefully and fill these things in it. Says cars waiting at stopped light when it does accelerate from rest. Tells you that start at rest and that the initial velocity 0 meters per second. Then we are going to accelerations. Then we are given the time or asked to solve for the change in position or the distance, and we are not given to solve for the final velocity. So therefore you can see, as I said, the positive side. We are given three things: to initial velocity, the acceleration, the time. We are asked to solve for force, and therefore we can get out for common equation and fifth out equation. We are going to use now how to figure that out. This is how we are figure that out. We want to solve for the change position. Therefore, the equation has to have to minimum the change in position in it. So let's look and see that the first equation have to change in position. Yes, it does have the change in position. So maybe I can use this equation well. The other things the equation has to have in it are the other three variables that we have given being. So let's C, do. We know the initial velocity. Yes, we do. We know the final velocity. No, we didn't know the final velocity. Therefore, we cannot use this equation. Let's look at the next equation. We are solving for the change in position. It has have change in the position. This equation does not, you cannot use that equation. The next equation, yes, it had the change in position. So we are looking for the change in position. It has that, it is a good sign. Now, do we know that other three variables in the equation? The initial velocity, yes, the time, yes, the acceleration, yes, and of course this time is the same at the time, we know the time, so therefore we know that we can use this equation now. Let's just check the last equation, and just for the check of it, it has final velocity. We don't know the final velocity, therefore we cannot use that equation. So we are going to use this third equation, and we are going to do that at the next slide. I bring all the information and the equation, and we are just going to fill the value and solve for the change in position. Now the other things you should notice in this problem with the equation is that the initial velocity is 0. The initial velocity times the times is therefore also going to be 0. So can simplify the equation because this term is 0. So therefore this equation becomes the change in position equal to half t square, and we know the acceleration, we know the time, and still the law students fill the values on half times 5.5 times 4.25 square, and you get that the car travels 49.7 meters during that 4.25 seconds. Okay, all we did was we wrote down all 5 variables, plug them, write down the known and the unknowns, figure out which equation we are going to use, plug the value, and get the answer with the correct units. Let's try one more. Suze is riding bicycle and she is running 8.5 meters per second. Suddenly she being close by crumbs the dog to get away. The accelerate at 1.5 meters per second square for 5 seconds, and we want to know what it have find speed. Once again, I am going to write down all 5 variables: initial velocity, final velocity, changing position, acceleration, time. Now I am going to fill in that thing that I know and the thing that I don't know. All right, the first things I know is the initial velocity 8.7 meters per second. The second things I know is the acceleration 1.5 meters per second square. The next thing I know is the time 10 seconds. We are trying to find the final velocity. We are not given the change in position or not trying to solve for the change position, and therefore now I can use my kinetic equation because once again I have been given 1, 2, 3 of the variable. I am going to store for the 4, and I need to have an equation that has the final velocity in it. So let's check the first equation. Does it have the final velocity? Yes, do. I know the other 3 variable will. I don't know the change of position, so automatically I am not going to use this equation. Now the next equation, do I know that final velocity? Well, I am trying to solve for the final velocity and have the final velocity here. Do I know these other 3 variables in the equation? The initial velocity, yes, I do know that. The acceleration, yes, I do know that. The time, yes, I do know that. So therefore I know that I can use this second equation. Now let's look at, just check the other 2 equations. Sometimes there is more one equation, you know, sometimes one is easier than the other, no. Now I am looking for the final velocity. This one does not have the final velocity. This one had the final velocity, but it also has change position, which I don't know, so therefore I can't use the equation. Now on the next slide, bring my information with me. I have my equation. Now I can fill the value because I know the initial velocity that get point 0.7. I know this relation, and the time 8 point given plus 1.5 times, then that 1.5 times 10, 15 plus 8.7 give us that velocity, final velocity 27 June 20, therefore 0.7 meter per second, as she tries to get away from Chomport, the dog. Okay, therefore there you have it. I think it is pretty straightforward. We want our brief description of equation use only for constant velocity. I told you, and you should always write down all 5 variables, fill in what you know and what you don't know, choose the right equation, plug the values and give the answer with the correct units. Okay, there you go. Now here I am going to put at the end of this video a link to some further problems using kinetic equation, solving for acceleration, final velocity, time, and so on. So you can link to these videos here for some additional practice problem, and hopefully you found this video helpful. If you cannot do all of the following 3 things, give me thumbs.